Welcome to The Explainer. So today we're exploring something that honestly feels a bit like science fiction, but I promise you, it's very, very real. We're looking at how just a single, simple bedside observation can instantly unlock data from hundreds of similar patients, and how that can absolutely revolutionize clinical decision-making.
Okay, so let's just dive right into this. Imagine a doctor standing over a patient, right? They're typing a quick note about what they're seeing. Now, what if that tiny note could instantly map out the future for that patient based on hundreds of people who came before them? Well, today we are breaking down the Avinash principle. It's this brilliant framework that takes incredibly messy, super noisy population health records and just collapses them into clear, highly actionable macro patterns right there at the bedside.
But first, we have to talk about the bedside data problem and why we really need to move beyond the AI guess.
Look, right now, doctors need fast answers. But relying on a standard, free-text, generative AI model, that creates a massive, frankly dangerous hallucination risk when actual lives are on the line. Think about a black box LLM guess. It's essentially just trying to predict the next word, which, sounds great if you're drafting an email, but it carries an totally unacceptable risk in medicine. What we actually need are normalized, deterministic concepts. To safely turn a doctor's query into an exact cohort match, we just can't rely on a language model's best guess. We need to lock these concepts down with formal code so they're totally auditable, rather than just generating text.
And this brings us to the secret engine behind all of this, SNOMED CT. You can think of it kind of like a universal barcode system for symptoms. It stands for the systematized nomenclature of medicine clinical terms, and it's not just some flat list of codes, it's an entire compositional clinical grammar. It assigns one canonical, normalized concept ID to every single clinical finding, and that's regardless of how a doctor happens to phrase it. This basically catches logical nonsense before it ever reaches a clinician, and it gives us one perfectly normalized surface for an entire patient cohort.
So let's track the data's journey, going from plain English straight to coded insights.
We're going to follow a real-world clinical question through an 8-stage pipeline. And I have to say, these first 4 stages work almost like magic. They take a doctor's natural language and transform it into a mathematically precise query, pulling up a matching cohort in literal fractions of a second. We go from input, through extraction and composition, right to retrieval. It all starts incredibly simply. A clinician just types this exact phrase in their own words: 60-year-old with fever, ascites, and low urine output. The absolutely crucial thing to understand here, the doctor doesn't need to know a single thing about coding. They literally just type what they see in front of them.
Once they hit enter, the system takes the wheel. A lightweight, totally deterministic layer maps those plain English phrases strictly to canonical SNOMED CT concepts. Fever gets an exact ID. Ascites, exact ID. Low urine output maps perfectly to the medical term oliguria and gets its specific ID. And the true superpower of this system? It absolutely refuses to guess. If it isn't completely confident, it just won't make a match. It demands absolute, uncompromising accuracy.
From there, these concepts compose into SNOMED CT's expression constraint language, or ECL for short. See those little double arrows in the query? That's the math telling the system to automatically pull in all descendant concepts. So it's not just querying exactly what the doctor typed, it's grabbing all the related clinical subtypes too, and nobody has to enter those by hand.
Then, this highly structured query hits a pre-computed analytics layer. Because everything is already pre-computed and indexed by these IDs, this happens as a rapid lookup, not some heavy, live calculation. The result? We get an incredibly specific 71.2% cohort frequency match, and it happens in sub-second time.
And that brings us to our magic number, 94. Out of an entire system containing thousands and thousands of records, exactly 94 patients fall into this highly specific result set. This instantly routes us directly to an active, critical clinical grouping that we call the renal hub.
Moving right along to generating clinical intelligence, it's time we actually meet the patients.
Now we actually get to look under the hood. What we're looking at is the real trajectory of a 60-year-old male from our matched cohort. It's a very precise and quite sobering timeline. He's admitted with fever and ascites on day 0. He hits a critical decision node, the hub, on day 3 with oliguria and a lactate rise. And unfortunately, it ends in terminal deterioration on day 9, even with an intervention on day 4. Yes, the data is coded and raw, but we always have to remember it represents real human lives.
All of this mapped data then instantly populates a standardized clinical intelligence brief.
Without you having to dig around in charts, you are immediately presented with clear presentation metrics, specific intervention protocols, and tracked outcomes. And because this brief is built on that normalized SNOMED CT data structure, it keeps the clinical facts completely grounded. You're entirely free from those scary generative AI hallucinations.
And then comes the real breakthrough. An insight report reveals the hidden patterns within that cohort. It highlights a very clear bimodal outcome. 91 patients stabilized their renal function, but 41 went into progressive renal decline. But here is the most valuable piece of intelligence. The system identifies that a lack of response to diuretics at hour 4 is the absolute strongest predictor of failure. This tells the doctor exactly what they need to watch for, literally minute by minute.
Next up, the aggregate graph, where we'll be mapping out these trajectories. So we're not just looking at a boring wall of text here. This actually renders visually as a fully interactive cohort trajectory graph. Every patient's coded chart overlays into a map, where nodes represent shared concepts. The rules here are just elegant. Nodes get sized by patient volume, they're tinted progressively redder as adverse outcomes rise, and the whole thing is fully pivotable. A doctor can trace exact, real-world transition pathways through the cohort's entire history. And right there in the center of that graph, a golden ring highlights the crucial hub node. For our specific cohort, that node is oliguria plus a lactate rise. This spot marks the critical clinical crossroads where the population dramatically branches, either into a survival trajectory or a failure trajectory. Knowing that you are standing at the hub node changes absolutely everything about how you treat the patient in front of you.
Finally, let's talk about a new evidence pyramid and bringing these cohorts directly to the bedside.
The sheer speed and honestly the structural integrity of this pipeline fundamentally upgrades our immediate medical reality. Now, to be clear, it doesn't replace traditional randomized controlled trials or systematic reviews. Rather, it acts as a real-time front door to the evidence pyramid for clinicians standing right there at the bedside. It completely takes the waiting out of clinical intelligence.
Let's just quickly recap the profound advantage we're talking about here. We are safely resolving plain language into formal, auditable queries. We're retrieving pre-computed cohort structures instantly. And most importantly, we are completely bypassing the incredible dangers of AI reconstruction and hallucination. We're delivering a trustworthy, pivotable graph that a clinician can actually rely on in the heat of the moment. Ultimately, there is one guiding philosophy behind all of this. It is the rigorous, standardized coding layer of SNOMED CT that guarantees this system is safe, accurate, and consistent. The coding layer is doing all the heavy lifting, ensuring that a hub node means the exact same thing for every single patient query. It completely removes the guesswork from the equation. So as we embrace this incredible new future of healthcare technology, we really have to ask ourselves a profound question. If your simple bedside observation could immediately and safely chart the future based on hundreds of patients who came before, how would that change your next life-saving intervention? The data's there, the structure's there, and now the pipeline is finally here. Thank you so much for joining me on this explainer. Keep learning, keep questioning, and I'll see you on the next one.